All right, so we're going to take a look real quick at anhedral, dihedral, and polyhedral wing shapes when we're building gliders. And we're going to talk sort of what's the point of a dihedral or a polyhedral and why it benefits us. So first thing first, I've got this real quick straw fuselage. It's just a straw. I put a pipe cleaner in it just so you could see it. And we're going to pretend that this is the tail of an airplane or a glider. And up front, I just sort of slit it so I could slide one through. So the first basic type of wing you get is your very basic anhedral. Okay, so basically the idea of an anhedral wing is that it is flat. Now, unfortunately, my piece of paper here is sort of bent on me, but the idea is it's a flat wing. Okay, and you control your wings or your roll. Okay, so once again, remember, roll is how the plane moves side to side. Remember, this is the sort of the front or the cockpit. So front of the cockpit and the tail. Roll is how it moves like this. Okay, so how it moves like this. And if you have flat wings, the only way you can really control that is through your ailerons on each wing, and they can control how your plane rolls in the air. Now, if you think about the four forces of flight, when you think about lift, if you have a flat surface, that surface is producing lift straight up. Okay. So as your vehicle flies through the air, the lift is expressing on the bottom of the wing, pushing straight up. So as it flies, the lift is pulling both wings exactly straight up. There's nothing balancing it. So if you don't have your ailerons set correctly, one of them is going to move back and forth. Now, a dihedral takes that flat wing away, and instead of having a flat wing, it actually introduces an angle between the planes of the wing. And that's actually what dihedral means, or the hedral means, is that it has to do with the angle between the planes of each wing surface. So in this case, I'm going to make it very pronounced just to make it very obvious. This has a large dihedral. Okay. And to measure that, you would measure the angle here, and it would tell you what the angle is of that dihedral. Now, we still have our ailerons to control that, but the big difference here is that as our plane moves through the air, the wing surfaces produce lift, and that lift comes at the bottom and basically pushes them in the same direction. So this one is pushing, instead of straight up vertically from the ground, it's pushing towards the center of the body of the airplane or the glider. And this one's also pushing towards the center of the body of the glider. So those forces come together sort of in the middle here. And what's nice is that with a dihedral, those forces tend to automatically make your glider or your plane want to fly level. Okay. Because those forces come together and they balance each other, and they just sort of sit and make your plane want to fly level. So while it flies, it may rock back and forth a little, but it sort of wants to go flat and straight. It's kind of like if you're in a car driving down the road, if you're going at speed and you let go of the steering wheel, your tires generally want to go straight. They don't want to turn off most of the time. They want to try and sit straight. With a dihedral, you can create that effect on your glider. It wants to lay flat to the ground, so it flies smoothly towards the ground. Now, the next step up from this, from a dihedral, is called a polyhedral. Poly meaning many, and that hedral still referring to the angle. So if I add a polyhedral, all that means is that instead of having a single angle change, you have multiples across the wings. So as it goes, you have a dihedral angle here and then another angle here. So polyhedral, meaning many angles. So 1, 2, 3 in this case. And normally the second bend is out towards the wingtip. You'll see this on real planes all the time. But again, this increases the amount of lift that's pushing towards the center body of the plane and wanting the plane to fly flat and level. Now, this comes at a cost because anhedral wings, the flat wings, generally want to just fly flat, and there's no loss due to drag. When you add a dihedral or a polyhedral, you're increasing drag on your glider or your plane, and therefore you have to increase thrust in order to maintain the same forward. So there is a trade-off, but the basics come down to this: a polyhedral or dihedral, which is anything that's got this bend in the middle so that your wing planes are at an angle, they try to fly flat to the ground, and it tends to center itself automatically. When you have an anhedral or a flat wing, okay, you're going to have some problems with it rolling and controlling roll without your elevators. So those are the ultra basics to anhedral versus dihedral and polyhedral wings, and hopefully they'll help you build your gliders a little better for this project.